Hello, this lesson will be our introduction to Earth's systems. So let's get started. Share my screen with you and close this out. And let's go to the beginning of it and press play. There we go. And I just want to double check that it's recording because I just did the whole lesson for you and I forgot to hit the record button. So we get to do this again. So introduction to Earth systems. You're going to get familiar with the four pictures in the corner. I'm going to minimize myself here. Am I at the very first one here? Yes, I am at slide 1. Okay. So the essential question we're going to be asking is, how do matter and energy cycle through Earth's systems? You're going to find out about these four systems that you're going to learn about today, and then we're going to be talking about all these different things that are in the corners in more detail in future lessons. So these are the science standards you're going to want to be familiar with. Throughout the year, we're going to be covering 8 primary science standards and various substandards within our 8 categories. So be familiar with the 8 categories, asking questions and defining problems. I'm going to have you asking lots of questions. Developing and using models, we'll be doing that in our first unit here very soon. Planning and carrying out investigations, analyzing and interpreting data, using mathematical and computational thinking, constructing explanations and designing solutions. We already talked about constructing explanations in our freshwater versus our saltwater ice melting example demonstration that we did. Obtaining, evaluating, and communicating information. You had to communicate to me the whys behind the ice melting in freshwater versus saltwater. So let's move on. Just have to click on that. Okay, what are our objectives today? Be careful to apply these objectives because at the end of the video, you will be answering the questions that these objectives are. So I can define a system. You're going to be able to define one. I can name 2 Earth cycles of matter and energy. I can list and define the 4 primary Earth systems. We'll be talking a lot about those 4 primary Earth systems. I can explain what drives Earth systems and give 2 examples of each type. And I can explain the 2 types of feedback and give an example of each. Our science substandard is at the bottom there. We're going to be able to develop a model to describe the cycling of Earth's materials and the flow of energy that drives this process. So let's get started on our lesson today. And throughout the lesson, it's a great idea to take notes and pause the video and write down the definitions and the different categories of things that you need to know. So here's a good note-taking opportunity. What is a system? I think I'll try to get some little icons where things are important to take down for note-taking. I'll have to do that in my next lesson. What is a system? A system is a group of parts that work together as a whole. So, for example, can you think of some systems? How about a school system? We are currently in the hybrid model in our school system. You might have some friends that are all virtual. You might have some friends that are all in person, right? So a school system is a system that works together with teachers and principals and students and parents and counselors and secretaries and gym teachers and music teachers and art teachers, right? Okay, here's another system that you may very well be familiar with, a computer system that includes the keyboard, the monitor, the CPU, right? And how about a sports system? That's a system, isn't it? Yeah, there could be different leagues of players or different players, teams in different leagues, right? So that's a sports system. So now we are going to be talking about what is the biggest system that you can possibly think of. The biggest system that you can think of. Did you say this? What is that? It's the universe, the solar system. The solar system is the biggest system, and it contains all the other systems that we're going to be talking about this year in Earth science. Did you know that the known universe is 558 trillion miles? And that's just the known universe. That's a lot of zeros, right? I don't even know how many zeros that would be. Let's see, 500, I just have to do this because I like math. 558, so that would be trillion. This would be billions. This would be millions. This would be thousands. And then we would have our units. So that is 558 trillions. Tens, hundred thousands, 10,000, hundred thousands. Oh, wait a minute. Tens, hundred thousands. 10,000, hundred thousands, millions. 10, hundred thousand, billions, trillions. Okay, I'm off. I have too many zeros. So 558 would go here. Cross off those zeros. So that's 558 trillion. So let's clear that and go on. Just wanted you to see that number visually. Earth is a system within the solar system, right? Because there's lots of different planets that have their own systems. Earth is one tiny, teeny planet within millions of other planets and solar systems and galaxies and that. So here is a picture of Earth from space. The Earth is full of its own systems that are all working together to sustain life. So the water cycle is one of Earth's systems that God designed perfectly for our ability to live and thrive on the Earth. And then there is the rock cycle. It's also one of Earth's systems. We're going to be talking more about the water cycle and the rock cycle in future lessons. So how are these cycles alike and different? How is the water cycle and the rock cycle alike and different? Now here's a picture of the water cycle. We're going to get more in depth in future lessons what all that means there. And the same with the rock cycle there on the right. So both cycles are going to involve the flow of matter and energy through different components. Okay. And the water cycle is going to explain the movement of water through the earth, whereas the rock cycle is going to explain the movement of rocks through the earth. So that's how they are different, but they are both cycles with the flow of matter and energy. Okay, what's this a picture of? There are 4 spheres or subsystems of the earth. Another great note-taking opportunity, 4 spheres of the earth. What's the first one? There's a picture of it there. The atmosphere. What is the atmosphere? Let's take notes. That is the thin envelope of gases that forms Earth's outermost layer. You know you're going to get a question with a definition of what is the atmosphere. So the gases in the atmosphere are mostly nitrogen, oxygen, water vapor, and carbon dioxide. And the atmosphere is what's responsible to make the weather and the climates that we have around the earth. And later on in the year, we're going to be discussing weather and climates in greater detail. And I think you'll find that a very interesting unit as well. So the atmosphere is that thin layer of gases around the outermost layer of the earth. This is the second sphere. What is that a picture of? That is the geosphere. And the word geo makes you think of geology, and you think geology is the study of rocks. Well, the geosphere is one of the systems involving the rocks of the earth. It involves not only the rocks, but also the metal that is in and on the earth. The geosphere includes solid metal inner core, the liquid metal outer core, and a rocky mantle and crust. This would be a great note-taking opportunity on the geosphere as well. And the geosphere is what we walk on. Yes, it is what we walk on. Pause the video if you need to. The third sphere, can you tell what it is from the picture? Exactly, it's water, right? So that is called the hydrosphere. Hydro means water. So All of Earth's water is part of the hydrosphere, including the water in the atmosphere. That is also part of the hydrosphere. There's a lot of water in the atmosphere. The cryosphere, and I'll underline that, it's kind of hard to see, it's right here. The cryosphere is a subsystem or a part of the hydrosphere, and this includes all of the frozen ice and snow on the land and in the ocean and in the lakes. That is the frozen water, cryosphere. Without the hydrosphere, we could not stay alive. We need water. Plants need water to grow. We need to eat the plants. We need to drink water to stay alive. The animals need to drink water to stay alive. We eat the animals, so we wouldn't stay alive without water. Here's the fourth sphere. Can you tell what that one is? This is one we're going to talk about a lot more in 7th grade. This is the biosphere. Think of biology. It's the study of life. Bio meaning life. So the biosphere includes that part of the earth that contains all of the living organisms. If you have a 7th grade brother or sister right now, they're talking about how you can know if something is alive or not. Living organisms include the plants, the animals, and you. Without the biosphere, nothing on Earth would be alive, right? It's all the living parts that move and breathe and reproduce. How about energy flow? Here's the 4 spheres. We have the atmosphere, the geosphere, the hydrosphere, and the biosphere. And again, we have this cryosphere here, which is a subset of the hydrosphere. Remember what it was? Yeah, it's all the frozen water. Cryosphere, and then the word sphere. All of these have the word sphere at the end. Sphere is like a ball, right? A sphere is a ball. So a sphere is a cycle when you're talking about these 4 types of spheres. So the atmosphere is a cycle of gases. The geosphere is a cycle of rocks and metal. The hydrosphere is a cycle of water, and the biosphere is a cycle of living things. So all of these cycles could not happen without the flow of energy. Energy is the ability to do work. So if you have no energy, you're probably going to not get your homework done, and you're probably going to sit on the couch and watch television or take a nap. So without energy, you can't do work. Same with the earth. The energy is needed for the constant cycling of matter through the 4 earth systems, right? So you're going to need that energy to cycle through the atmosphere, the geosphere, the hydrosphere, and the biosphere. Energy is going to drive the cycles of matter in the 4 spheres. So what are the 2 main sources of energy on the earth? Remember we said we have 2 energies. The 2 main sources of energy, can you tell that sun is number 1? That's a big one, right? Do you know the second source of energy for Earth? It's the heat inside the Earth. So the Earth's interior here, you have the inner core, the outer core, you have the mantle, and then you have the crust, right? So there is heat, lots of it, inside of Earth's ball. What is feedback? Okay, we're going to talk a little bit about this. This kind of relates to the experiment or the demonstration we did in the previous video, talking about the melting of ice in fresh water versus the melting of ice in salt water. So what is feedback? Feedback is a loop in which one action triggers another action on the earth. So if your brother steals your game system for the day and you want to play with it and he's got it, that's going to trigger an action in you to go and yell at him, right? And then he's going to yell back, and then that's going to trigger the action of mom coming and saying, what's going on? Why are you two fighting? Right? And then maybe she'll punish both of you or take the game system away from both of you. So that's another action that's been triggered by your fighting. So feedback is an action triggering another action. So how does that work on Earth? Well, it's an action and an effect and an action and an effect. Let's see how it looks. There's 2 types of feedback. There is positive feedback, and that is the speeding up of a process. And there is negative feedback, which is the slowing down of a system or a process. I have the slowing up of a process. It should be the slowing down of a process. Makes more sense. So what's an example of positive feedback? Well, let's talk about this ice, these glaciers. Glaciers are great big stacks of ice, right? So glaciers are part of the hydrosphere, which it's actually part of the subpart of the cryosphere because it's the frozen water on the earth, right? So it's part of the hydrosphere, and glaciers keep things around it cool. So think about when you put ice in a cooler, you get your soda colder, right? So when you're standing on a glacier, it's going to keep things around it cooler, including you. So many glaciers, however, now are melting around the world. So as glaciers melt, they turn into water, which is going to run into the ocean. That, by the way, glaciers are fresh water. That's from the rain and stuff like that that comes down and freezes, right? So when the glaciers melt, most of it's going to run into the ocean. Some of it's going to evaporate into the sky as well, especially when you have great, big, huge amounts of glaciers. Some of that water is going into the sky. So then what happens is more land is exposed to the sun when the glaciers turn into water. So the water runs into the ocean, and now you got the land exposed. But when the land is exposed to the sun is going to heat up the land more because the land can absorb the heat. When the land heats up more, the air around the land is going to get hotter. And when the air around the land gets hotter, the glaciers are going to melt even faster. Remember, positive feedback is an example of something process speeding up. More melting is going to happen. So glacier melting faster is a positive feedback because the melting is speeding up due to Earth's processes. Remember that glacier melting faster is positive feedback. Let's do an example of negative feedback. It's a picture of some clouds in the sky. So let's think about this. After the glaciers are melting and the land is heating up, and then the air around the land is heating up, the atmosphere is going to start getting warmer, and it can hold more water vapor when it's warmer. That's why in summer you get more sticky, humid weather, because more warmer air can hold more water vapor. And more water vapor means we get more clouds. Clouds are just water vapor in the sky. So the more water vapor in the air, the more clouds we're going to get. And if you think about it, what happens when we get clouds? Well, it blocks the sun, and then do you think about it, it's cooler outside when the sun isn't shining, right? When there's clouds out instead of the sun, it's not as warm. So let's think about this, what's going to happen. So when you block the sun by the clouds there, you're going to create cooler temperatures on the ground. When the cooler temperatures on the ground, that's going to cause your air to get cooler around it again. And the cooler air then is going to slow the glacier melting. So this is an example of negative feedback. Glacier melting slower is negative feedback because the melting is slowing down due to Earth's processes. So glacier melting slower is negative feedback. Come back on here. So here are the questions that you're going to be answering on Google Classroom. I will have these questions up as an assignment for you attached to this video. These are the these are the objectives from the beginning slide. And you're going to need to go back and answer these questions. And if you took notes, you probably have all the answers already. What is a system? Name 2 Earth cycles of matter and energy. List and define the 4 primary Earth systems. Hint, hint, they have the word sphere in them. Explain what drives Earth systems and give 2 examples of these different types. Think about the big word with an E in it, not the Earth word, but the other E word. And explain the 2 types of feedback and give an example of each. Be able to give an example and explain that. So that is the end of our first science presentation, and we will be back soon. So good luck, and we'll see you next time. Bye.